Alright, this is 2-2 in pre-cal. We're going to look at interval notation for functions. This is another way to write the domain and range. We wrote it in set notation or set builder notation in 2-1. Now we're going to look at interval notation. Interval notation uses two endpoints, and then it uses brackets, and the brackets will tell you whether the endpoint is included or excluded from the domain or the range. So let me start by giving you a couple notes. And what we use two kinds of brackets. We use a square bracket that looks like that. And if you use a square bracket, then that number that it's next to it is included. That would be your less than or equal to or greater than or equal to. It's included in the domain. Okay? If you have a curved bracket like this, that means that the domain or the set of solutions gets very close to that value, but it doesn't include that value. It never gets quite to it. So that'll be your just less than or greater than symbols when you see those. And these are examples here. You can see x is greater than a. Well, it starts at a and goes to infinity. If you drew that on a number line, you would have the open circle at a and the arrow would go to the right. X is greater than or equal to a, you'd have your closed circle and it would go to the right. Well, instead of open circles and closed circles, you're using a curved bracket if it doesn't include it, and a square bracket if it does include the variable, or the value, excuse me. Less than a, you could have a curved bracket and then it would go to the left. Less than or equal to a, square bracket, and go to the left. Now, since it's going all the way, never ending, that line, it goes to infinity. If it's going less than, it's going to negative infinity. And you never get to infinity. You can only get towards it, so that's why you have the curved bracket. If you're between two endpoints, you have a comma b, and then you pay attention to the brackets. In these cases, they would both be square brackets. These would both be the parentheses or curved brackets. This by the A would be a curved bracket, and by the B would be a square bracket. And that's done with letters. So let's do a few examples with numbers, because it's always easier with numbers. So we have between 3 and 5. So we have 3, 5. And they're both less than or equal to, so we're going to have square brackets around each of those. And that means anywhere from 3 to 5, including 3 and 5, is the solution set or for this domain. 3 to 5 without the lines underneath, 3 is less than x, which is less than 5. You have your parentheses type brackets or your curved brackets, and it goes from 3 to 5 like that. So the only difference is the type, in these two things, are the type of bracket. Now here's another 3 to 5. Let's look at this one. Now it goes from 3 to 5. Okay. It doesn't include 3 because there's no line under there, so you have a curved bracket. But it does include 5, so you have a square bracket. So you can have both types bracket on the same interval. X is greater than 5. That means it starts at 5 and it can go bigger. So it's from 5 is the low number. You always put these in number line order. And infinity will be your high number. And it's greater than or equal to 5, so it includes 5, square bracket. And of course we never get to infinity, so that's a curved bracket. All real numbers, that's if you colored the number line in solid, every number. So we go from negative infinity to positive infinity. Curved brackets on both ends. So use this as your examples and your reference as you go through and do the homework. X is greater than 5, but not greater than or equal to 5. It's going to look just like C in terms of what's inside the interval, but they're both going to be curved brackets because it doesn't include 5 this time. Less than or equal to 5. Remember, we're going to negative infinity. We list that first because that's the lower number. Always list it in number line order. So it goes from negative infinity up to 5. That's everything less than 5. It includes 5. Square bracket. And then a curved bracket around infinity. No solution would be an empty set, which is just a kind of a 0 or a O with a line through it. That's your empty set. And I put a little curve up there at the top. That's not meant to be a curve. It's meant to be a straight line. All right, state the domain and range of this curve. Remember, always read it from left to right. So our x value here, well, you have to pay attention. There's an arrow there. So this goes on and on as you follow that line. The x's are getting smaller. So it could go to negative infinity down here. And the highest value of x is right here at 7, between 6 and 8. But look at the dot to make sure, does it include 7 or does it not include 7? It looks like it does. So our domain is from negative infinity to 7, and it includes 7. Now we're looking at the range. Our lowest point appears to be right here, but it's not, because this arrow, remember, goes down, 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 down. That keeps going down, 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 down in that trend. So again, our range is going to negative infinity, okay, and it's going up to, read over here, 4. Okay, so we're going from negative infinity up to 4, and it includes 4, and of course doesn't include infinity. But this is a caution, because it looks like you should include that line, but with that arrow there, it goes farther. You always go to the lowest point on the graph. And is this a function? Again, you do your vertical line test, and yes, it is a function. So let's look at our next one. Let's go to our next one. We'll go scroll down here. Okay. Again, we're going to look at our graph. Now this time we don't have arrows at our endpoints. We have dots, so we do have endpoints. First question, is it a function? Yes or no? Yes, it's a function. What is the domain? Well, the lowest value of x here is negative 4. So we go to negative 4, and the highest value is up here at 9. Always look on the x-axis for those domain values, and then you read your graph down to the x-axis. Negative 4 is this open circle there, so it's not included. Right there, it's an open circle. This 9 value, where this point would have a value of 9, negative 2, so the x value is 9, and sometimes it helps to put those points on there. This one is negative 4, 5. Okay, so you can look at your x values and see what they are. The 9 is included, so it needs to be a square bracket. Now look at our range. We don't have any arrows, so this is our lowest point. We have to kind of guess. It looks like it's 2, 3, about halfway between, so we're going to say it's negative 3.5. It's hard, you're guessing. Okay, does it include that? Yes, because it's a closed circle there. And it goes, the highest value up here is 5. Actually, we're not guessing because that point is given to us on the graph. Highest value is 5, and it's not included because it's an open circle. Now, what is f of 3? If you were given an equation for a function, you would plug that 3 in for all the x's. But when you're given a graph, all you have to do is go, that means your x is 3. So this means, okay, what is y when x is 3? That's what that means. So you look at your 3, x, and read down here, and y is negative 2. So the value of that is negative 2. F of 3 is negative 2. Where is f of x? Where is f of x equals 3? Okay, so in this case, y is equal to 3. What is x? So you look at your, where is what? Look, I'll go on your graph. Here's where y is 3, right here. Okay, read down, x is 6, so x is equal to 6. But there's another place, look over here. Y is 3 here too, so x is also -3. So it's both those values because there's 2 points that have a y value of 3. So let's see, what is f of 0? So again, x equals 0, that's telling me that x equals 0. What is y? So when x is 0, you go down here, looks like y is -3, or f of 0 is -3. Okay? Where is f of x equals 0? So where is y equals 0? So if y equals 0, what is x? So here's y equals 0. Okay? In other words, where does it cross? This was asking for x-intercepts. So x is 0 at -3, 4, and 8. Or that's -2, sorry. Okay, so at -2, 4, and 8, you have a value of y equals 0. Now what are the x-intercepts? The x-intercepts, again, are where it crosses the x-axis. So you have x-intercepts at -2, 0, at 4, 0, and at 8, 0. Okay, so you have your x-intercepts. And the y-intercept is where it crosses the y-axis, so that's where x is 0. So your y-intercept will be at 0, 3. Okay. And that will finish us up for 2-2.